Hello, everyone. Welcome to this session of IAP course for Deep Learning for Art, Aesthetics, and Creativity. Today, we have two special speakers, Professor Alyosha Efros from Berkeley and Professor Phillip Isola from MIT. They are both great scientists in this area of especially generative models, and they have done together generative modeling for instance, peaks-to-peaks, cycle consistency with scans, and many of the more recent generative model that you see actually benefit from their work. So let's have them start the conversation and see how they want to lead the session.
Cool. Thank you for the intro, Ali. So we have a somewhat unusual lecture in mind where we both prepared some thoughts and we'll give a short talk each. And then I think we're going to ask each other questions and enter kind of a dialogue as well. And yeah, I think we can see how it plays out. And as far as I'm concerned, if anyone wants to interrupt and ask questions or participate, that's great. Feel free to just jump right in. So Alyosha, I'll go first with the short talk. Okay, so let me share my screen. Okay, can you see the screen? Okay, good. Yeah, this will be two somewhat different topics, but they're all about methods and ideas about art and AI and creativity. And what I'm going to talk about is the view of generative models as a kind of new type of data. So we know and love data. Everything is data-driven. You can do a lot of interesting creative projects with data and mining data and linking data up together. And something new has kind of come along and started to work really well the last few years, which is generative models. And at first, it looks a bit different than what we're used to working with, which is maybe data. But what I want to argue here is that the current era of generative models, the current kind of generative models that we're looking at, they're just like data, but better. Okay. So first, since I know that the audience has probably a variety of backgrounds, I want to just describe, what is a generative model? What is this thing that we are going to be looking at? And my favorite way of understanding this is this little demo that someone made and posted on Twitter, where what she does is she's going to draw a picture of a tree, but the way that she'll draw it is she will roll some dice, and the dice will tell her which direction to branch. And then she'll roll some more dice, and those dice will tell her, again, which direction to branch. And another combination of dice might tell her whether to add a flower or a leaf. Should it be a big leaf or a small leaf? So this is what she does. She keeps rolling the dice and does exactly what they tell her to do. And you can see the kind of lookup table on the left is telling her how to map the dice roll to elements of the tree. So that's kind of cool, fun, creative project. It turns out this is exactly how generative models work these days. You roll a bunch of dice, and a deep neural net or some kind of lookup table type function will tell you how to map the dice rolls into pictures. So you can use these things to make really interesting content, random trees. But these days, what we're excited about is that you can also use them to make just photos. So in a little bit more detail, here's how it works. You roll some dice. So you take a random number generated from some Gaussian noise. And then you put those random numbers into a neural network. And if one of the dice comes up 6, then it might say add an eye. Another one comes up 5, it says add some ears. The neural network, which I won't really describe, is able to synthesize an image of a fish. Roll the dice again, I get an image of a duck. And you can make a lot of different photos in this way. So it's a cool tool, but at first it seems a little bit like we didn't really get much out of this, because what you do to train this system is you show it a ton of images and you try to train it to be able to make more images. So the input to this system is actually a big database and the output is another big database. So what did we really get from this generative model? We can make random images. Who cares about making random images? We already have random images online. And I think the key thing that you get out of this, or one of the key things, is you actually get not just random images, but you get a mapping from these noise variables Z to the random images. And that mapping is what gives you a lot of power, which I'll be describing. Okay, so yeah, question.
Yeah, no, it's about your the view panel. I think that we have. Do you want to put just yourself as the speaker?
Yeah, I think that's fine. But yeah, the slides and me is fine. Yeah.
Yeah.
Yeah, that's good.
Okay.
So, you know, and we all know and love data, images, and we can think of these samples from a generative model as like data, but they have this extra latent variable Z that what you can do with that is it's kind of like the DNA of the image. It's the instructions that tell you how to make that image. And you can modify that instruction to do things like make the mountain explode. And in that instruction space, in that Z space, that DNA, you can navigate this continuum of the manifold of natural images. And that's something you can't really do with just raw data. So you get this data point, but it's decorated with extra functionality because it has this DNA attached. Okay, so we had data, and what a model does is it fits that data and it interpolates and maybe even extrapolates a little bit to create this denser manifold of natural images. Okay, so these are things that people know. I'm just giving a slightly new story. It's just a way I like to think about these generative models. They're like data, but with extra functionality. Okay, so we've been developing, and a lot of other people have been developing various ways of working with this kind of data, this data plus. So images, but also the instruction set that generated the images and mappings to and from that instruction set. And I'll show 3 quick examples. So one thing that you can do is you can interpolate between images in a way that's more semantically meaningful. You can manipulate images by manipulating this DNA. You could compose images in this latent DNA space. And I think that there's a lot of really interesting applications in graphics and art and creativity, also in scientific visualization, as well as things like data augmentation. Okay, I'm going to focus mostly on the graphics and the visualization. Okay, so the first thing that you could do is if we go into the latent Z space, this DNA space, and we pick a point that will map to a particular image. It might be an image of a bird. We can pick another point that will map to this image of the fly. And if we just walk on a line, interpolate between those 2 DNA vectors, Z, that will map to this smooth path along the natural image manifold. And this is something that you can't really do with just raw data. If I interpolate between 2 images in pixel space, you get this blended image, which doesn't look very realistic. But if I do it in the latent space, the Z space, you get something where every intermediate image looks like a natural image. It looks like a half fly, half bird. So you can start to see that this opens up some space for creativity or creating things that humans have never seen, which is quite interesting. Okay, let me see if I can check the chat because I noticed there's a question here or something. Oh, okay, looks good. Okay, So another thing that you can do is something that actually Ali worked on along with my student Lucy Chai. And maybe Ali, you talked about this on Friday, so I'll just very quickly talk about it again. So can we edit images in this latent space? And the idea here is that we want to find a way to manipulate this data object via a simple arithmetic operation. And inspiration is models in natural language processing, like the word debate model, which maybe you've seen. It turns out you can also create these latent codes for words, and you can do simple arithmetic to navigate from present tense to past tense, or from male to female gender, for example. So you can do that in images too. And the way it works is you search for a direction to walk in latent space that will map to a meaningful transformation in image space. So here we're searching for a direction that maps to shifting this daisy upward. Okay. So that's a mathematical optimization process. We look for a direction W such that Z, the latent code for the daisy, plus W in latent space, so modifying its DNA in this linear fashion, will map to a daisy which matches an edited version of the daisy. So we're trying to learn a transformation in latent space that will be equivalent to some specified edit transformation, in this case, shifting the image up. And that can work. And the really neat thing is now we can take an image and we can edit it. There exists this kind of zoom in vector in latent space. We can apply that. That will zoom the cat in. It's a bit shaky. We can shift the cat left and right. We can take an image. We could say, what direction in latent space will make it brighter? What direction in latent space will make it darker? And the cool thing is that it's not like a Photoshop operation directly on pixels. It actually snaps to the semantics. So editing the latent space to make an image darker knows something about the manifold of natural images. It knows that to make a volcano darker, it's got to explode, because all photos of dark volcanoes are taken when they're exploding. Okay, so we can edit these images. That's something that you can do that's more semantic than you could do with traditional Photoshop operations. But maybe it's not super exciting just to make an image brighter or darker or shift it up and down. Maybe we know what it looks like for this Arctic fox to go into a winter landscape. It's a cool graphics trick. But could we visualize things that are going to be more scientifically revealing? And we wanted to look at this. And so we did another project where we asked, could we visualize what it looks like for an image to become more memorable? And this was with Laura and Alex a few years ago. So we can do the same kind of operation. We take an image, and it's one of these kind of data plus plus images, so it has an associated latent code Z. And we can search for a modification of Z that when you generate the image corresponding to that modified Z vector, it will be assessed by another neural network to be high memorability or lower memorability. You could do this for any type of attribute you care about that you can assess. Okay, so when I take this image of the dog and I adjust it in the direction that the model thinks will make it more memorable, it kind of zooms in on that dog. When I adjust it in the direction that will make the model thinks it to be less memorable, it will zoom out and make the dog all pixelated. Okay, so the type of kind of visualization or visual definition of this concept of what it means for something to be memorable. And again, you can do this for any attribute that you have a model for. So if I have some model for predicting if an image is aesthetic or predicting if it has positive emotional valence, I can search for a modification of its DNA that will make it more aesthetic or more positive valence. And you can start to see interesting differences here. So the dog we can make less memorable or more memorable, kind of zooms it in. This beach landscape becomes a lot brighter and again more zoomed in when you make it more memorable. Aesthetics has a slightly different transformation. It doesn't really zoom objects in, but it does make them very saturated and have nice kind of bokeh effects, nice blurry background. If I make the dog have higher emotional valence, it becomes very cute. If it's lower emotional valence, it looks a little bit stressed. Okay. So I'm just giving little snippets of what this new type of data can do. One more interesting property is it has kind of nice compositionality, where I can take different parts of different images, I can add them together, and I can generate a new image, which is the composition of all those parts. You can do this in pixel space. This is just making a collage, but it looks pretty bad. If you do this by composing the latent codes in a particular fashion, you can take this couch and put it on this background, and you get an image which has that composition but looks natural. This is another recent project that we put out with Lucy and Jonas. So what we mean by compositionality is that you can take some context and you can paste in an object into that context, and they compose in a way that is somewhat independent. So that tree can be on any background, or any tree can be put in front of this church. So here's the result of adding different trees to this image with the church. And you see that you always get a tree in there. The church might change a little bit, but there's some degree of independence between these parts. Okay, so we did some little study on that, but I would say much more impressively, there's this recent project from OpenAI called DALL-E, where they really scaled this stuff up, and you get just remarkable degree of compositionality. So what you're seeing here is that you can enter a text prompt, an illustration of a small green mouse sitting below a large blue elephant, and it will make images of that. And if I just change it to be an illustration of a small green mouse sitting below a large red elephant, it works. I can change the color of the elephant without changing other aspects of the image, without destroying that it was a green mouse. So there's some independence between these different attributes that we're specifying here. So these generative models are getting better and better, and these nice properties like editability, compositionality seem to be popping out and emerging more dramatically. Of course, there are limitations. So if we try to edit the DNA of this hot air balloon to make it move up or down, we can do so, but it kind of gets stuck at the top of the image and the bottom of the image. And if you graph it, you can see it gets stuck. And there's some bias here in the data that's being reflected in our ability to shift that hot air balloon up and down. It turns out there's just no photos of hot air balloons that were used to train this model that have the hot air balloon at the very edge of the image. And so the model reflects that bias in the data. Similarly here, if I ask DALL-E to paint a large green mouse sitting on a small red elephant, well, the mouse gets bigger, the elephant gets smaller, but not as small as the green mouse here and the red elephant here. Elephants are almost always depicted bigger than mice. And so it's easier to draw a large elephant and a small mouse than a large mouse and a small elephant. Okay, so yeah, the big picture point I want to make is that generative models are like a new kind of data. You can think of them that way. They're data, but decorated with this DNA and the mapping tuned from that DNA. And these objects, these decorated objects, can be manipulated, edited, composed in interesting ways. So what you could do with data, you might want to try doing with samples from a generative model, or what I'm calling data plus plus. Okay, I think I might end there just for time, but we'll go back and have dialogues about maybe some of these points. Okay, thank you.
Okay, so maybe we can have some questions now, and then have more questions later. And I'm very hopeful. I'm hoping that we don't have that many people, so I think everyone should just, you know, open up their mics and contribute. But I wanna start with saying that I think that this is something that is a very fresh perspective on generative models. That I like the story of data plus plus, or I guess another way to think about it, if you're into object-oriented programming, it's kind of like it's like classes, and you know, you have your data and your methods encapsulated as one thing, right? So for those of you guys who are into programming, this is a nice story. I like this story a lot because I think it makes for people, for example, like Adobe, this is a very clean way to think of data. Their data is no longer a JPEG that you download from a from a camera, right? Your data is this set of weights for your neural network that you can load up with the Photoshop, and then suddenly, you know, your sliders come alive and do your bidding in a way that pixels in JPEG never did. But I think there is something that's a little bit remains unsaid or under constraint here that I wanted to explore, and that's basically, you can also say that your normal photograph, your pixels, are also this kind of data plus plus. You can interpolate between pixels. You can get, you can take two images and go draw a straight line between them, all that stuff, and that's not what you mean, right? And it's not what you mean, because it's not going to look real between, right? It's going to go jump off the manifold. Is that right?
That's right. Although I do think that perspective is useful too, that you could also just take regular data like pixels and apply or learn operations on those. But yeah, I think the qualitative difference is that by doing it in the latent space of the model, everything becomes natural. It fills in all the gaps in a way that's, you know, more meaningful.
Right. So this brings me to my question, which is, you're only constrained while you're navigating your manifold is that things look real at all times, that you're never off the manifold.
Yeah.
But one could say that this constraint might still allow you to have infinite ways to go from A to B. How do you choose which way?
Mm-hmm. Yeah, so that's interesting. One thing that seems to pop out is that it chooses kind of the shortest way, and what often looks like the most natural way. Because yeah, of course I could go from volcano to sunset to different times of day, and then back all the way to the daytime volcano. But it doesn't do that, and I think that, yeah, it's more than just interpolating between images in an arbitrary fashion. It's kind of about finding the geodesics, like finding the shortest paths on that manifold, and maybe the shortest paths are going to relate somehow to things that we consider interpretable, or actually we call like the true transformation.
Right, but it seems to me that there is something else that might be involved here in conditioning your walk, which is basically like what are you meaning to do? What is kind of, in what sense are you trying to connect the images? Because you can think about, I don't know, you can think about trying to connect an elephant and a mouse in terms of like going from an elephant to a mouse, in terms of what are they called? They're both mammals, right? So basically, kind of sort them by arrange them by mammals of the correct size. So you go from the biggest mammal, which is an elephant, and then all the way to the smallest mammal. That's one way to order, kind of make a path. Another way to make a path might be on shape, right? Forget about mammals. I don't care about take all the objects in the world, but just make sure that that you have a smooth variation between the elephant shape and the mouse shape, and then you can have the same thing for texture. You can, right? There's multiple plausible and I think I would say reasonable ways to pass between those 2 points that, in a way, like if I was a Photoshopper, I might want to have access to all of them or many of them.
Yeah. So yeah, I totally agree. And just walking on a straight line it just picks one, and maybe it reflects the model biases because maybe it loves to pick color since a lot of the signal is just coming from the overall color of the image. But one cool thing, I don't know, Alyosha, how much you've looked at the DALL-E examples, but I have to say I've been was pretty surprised at what it can do.
I'm very impressed too. Yes.
Yeah, and one thing that you can do is in some of their examples, at least, of course they haven't released it, but just on their website they have examples. You can say, I want this elephant to have the texture of this painting, or I want this elephant to have the shape of this painting.
Right.
And if you do texture, it makes it look textured, and if you do shape, it matches the shape.
Right.
They had like make a teapot with the shape of an elephant versus make a teapot with the texture of an elephant, and it does different things. And I think that's because, so their latent space that they're using here is not just this random noise that we have been using. It's actually language. Right. And to me, that's kind of the big idea of DALL-E, is that language is a incredibly powerful latent space. Maybe it's closer to what we humans have as our kind of latent space. Although that's another debate.
Right. I mean, I think I wouldn't call it language. I would call it, 100,000 dimensional class vector. Because, or maybe even bigger than that. I think this model is not actually understanding language, but it does understand maybe words and maybe diagrams. Okay, and that allows you to go from something like 1,000 dimensions in ImageNet to 100,000 even more dimensions of these single words and diagrams, which allow you to have many plausible directions. So I think that's maybe the kind of a cool argument here, that we always talked about how it's very important to have lots and lots of data. These things are very data hungry, and of course this method is also extremely data hungry. But we also know that the more classes, the more categories you add, the richer your representation becomes, right? So I think it's also showing you that it basically you increase the number of classes, all the classes are fighting with each other, and then they are discovering different directions. So I think that's the cool thing here. But on the other hand, in DALL-E, you get those directions. You don't have to discover those directions. They are basically given to you from all of this ginormous amount of data that you have scraped from your language model and there's also the other thing here is that they're actually not scraping the internet. They're scraping Google image search, which itself is a very deep neural network, right? So there is a lot of human supervision that kind of goes in this whole loop, right? So they're scraping Google image search, which has been trained by users and click-throughs, and also trained by, started with ImageNet, which was also trained by users. There's a lot. I wouldn't call it unsupervised by any means.
Yeah. So actually so I was jotting down some of the kind of questions to talk about, and one of the themes was, are these models really creative? Are they really extrapolating? And I would argue that DALL-E is much closer to imitation learning, or not really creativity, because yes, it's built on top of language, which is a human construct, and it's trained on, highly curated, artificial data.
Right.
Whereas these methods that find these latent directions as an emergent phenomenon, just without kind of a human prior of language, or it's still curated data, but the latent space is just Gaussian. Those are a little bit more emergent. Yeah.
So we have a couple of questions on the chat, but I think it would be better if the people could just ask them themselves. How about we have David? Do you want to ask a question?
Yes, I was wondering if the mapping of the latent space is bidirectional, or if it's just from the latent space to an image.
Yeah, so in general, it can be bidirectional. And of course, this kind of paradigm summarizes over a million different things people are doing. And some people train models that are one directional, they just go from latent to image. Other people train models that go the other direction, they go from image to latent. Those are often called representation learning, or like image features. And then other people train models that go both ways. And I would say going both ways is definitely the best, if you can do it, if you can afford it. So just to be specific, variational autoencoders are a kind of generative model that goes both ways, whereas GANs, most of the results I showed are a model called GANs, if you know that. Those usually only go from latent to image, but going both ways allows you to do a lot of things that you can't do if you can only go one way. So, I pulled up this slide because you can kind of think of it as you have a data point, and then you have operators that go to and from the latent code. So G goes from Z to X, and G inverse goes from X to Z. You could also imagine decorating this with more operators, like transformations in latent space or transformations in data space. And like Alyosha, you were saying that, well, Photoshop can do transformations in data space. So yeah, we could also consider this first-class object of transformations in pixel space. So maybe we should add a function T there. It goes from X to X, and another function, H, that goes from Z to Z. So you're just navigating between different spaces and different transformations of this spaces.
Cool, thank you.
We have another question, or maybe it's a comment.
Yeah, so I've been looking at like machine learning and biology recently, and I've noticed that at least specifically with DNA motifs, there has been, it seems, no use of GANs or generative models at all, or even autoencoders. And so I was wondering if maybe like it just isn't at a point where it's useful in biology, or if no one's really put the work in yet. Because biological data nowadays, there's so much of it being generated that you would have a large training set, at least for like things like DNA sequences and things like that. So it's not a question of do we have enough data, Sometimes we have too much data.
It could be too much data or too hard to work with. Yeah, I don't know too much about the biology side of things, but I do know there's a lot of interest in those communities, and there are generative models of molecules now and proteins, and so there is some, there are steps in that direction for sure. I don't think it's been as successful, maybe because this stuff came from more the machine learning community, the computer vision community, and those communities just love working with pixels and MNIST, and it just hasn't expanded yet to all the other domains. But yeah, no, my belief and hope is that you can take any big data you have about it, whatever, biology, ecology, whatever, fit a massive generative model to it, and you'll get some of the same properties. That's, eliding over a lot of details.
All right. Are there any more questions, or should we switch to the other story?
I have one question. So actually for both of you. So this is very intriguing that there are several directions that Phillip is showing that one could do with this notion of data plus plus and generative models. So what is your suggestion for students who want to do some direction in this research research in one of these directions? Sounds like there are several directions, and what do you suggest?
So, okay, I skipped this slide because we're running short on time, but I think this is a good time to bring it up. So my kind of speculation about the next several years is that we're going to have more and more of these massive generative models, and more often we'll have available models that you can download online. So here's a repo of style GAN models. So for anime, for different types of art, for faces, for fireworks, you can download a generative model of that type of data. And you can sample from this model and make a million different fireworks and compose them and edit them, and you can do everything that I showed. So we're getting more and more public models like that. But at the same time, the data that train the models is getting to be really big. Sometimes it's private, has other issues. For example, maybe the two biggest generative models that have been talked about a lot publicly are DALL-E, which I described, and then GPT-3, which is a massive language generative model. But the data is not public. You can access model samples for at least GPT-3, and you can build applications on top of that. So I think that more and more we're going to have an interface to data, which is through models. And so more and more it's going to be important to figure out how to work with models, or data plus plus, if you like that, rather than working with data directly. The models are an interface to the raw data, but they're an interface that has all this extra functionality, and there's different requirements and constraints and computational profiles to that setting. So my what I'm working on, doing some stuff with Ali actually, is how do we create tools for the era in which we have less reliance on data sets and more reliance on massive generative models. I think there's a ton to do there. All of data science can be done in data plus plus space.
That looks very exciting. Alyosha, do you have any comment?
So I've been thinking a while about these directions in this space. What if you're sitting in the data plus plus story, if you're sitting at some point and let's say you want to be creative, or you want to explore that space, where do you go in this very high dimensional space? And so maybe then I should just do my spiel, and then we can both talk about that, because my story is basically about that, and then we can you see my my picture, my slides? Okay, so this is going to be completely science-free talk, or really remarks, but hopefully by the end we'll get to something that I feel it should connect with what Phillip was saying. And since this is an art class, I'm going to illustrate this with some art. Okay. And of course, as any art talk, you have to have an obnoxious title that is too grandiose, and there you have it. Obnoxious, grandiose title you have. Okay. So let's start from this image here. Okay. So this is something, I saw this a few years ago, this image, and it made a deep impression on me. It really touched something in me that I was very surprised about. And this is a photograph from a artwork by Michael Galinsky called Malls Across America, which are photographs that he took in 1989 in different malls in the US. Okay. And you can see that this is a late 80s, and you know, you have these, you know, the obvious telltale signs of you know, the hair and the pants and you know, the shirts and tape whirl here. And the thing is that it really made a huge impression on me, much more than I suspected, because this was the year that I came to America. This is the year that first time that I actually saw a mall, and it made a huge impression on me. But I didn't even have words to describe this. Like, you know, I didn't know any English for once, right? So I didn't have, unlike Dali, I didn't have any words to describe this. I had no idea what this thing is. I still don't know what this kind of haircut is. But it made a huge impression on me then, and now, so many years later, seeing this image again made a huge impression on me again, because it connected me to that time, and this image spoke to me in a way that I was very surprised that it was so powerful. Okay. And I'm sure that for other people, it may be, you know, who weren't in the malls in America at that time, it wouldn't make a big deal. Okay. So probably for Philip, who is younger, you know, this is like, doesn't have any connection at all. Okay. And so this, I think, illustrates a very simple but also very powerful point, that art requires context. We're appreciating an artwork like a photograph given its context. It doesn't live in a vacuum. It is always situated in the context, and the context could be different. The context for me for that painting, for that photograph, is very different than Philip's context. Okay. Here's another one, and it's magical. You think this is okay? This is a pretty well composed photograph for those of you who are into photography. This is nice. This is nice photo. It's a nice composition. You have the space. You have this girl looking at the sea. But to me, it's so much more than that. Like, I can smell the smells of these 80s malls. I can hear the stupid muzak and the speaker. Like, all sorts of other sensations are brought back to me just looking at this photograph. Okay, and it's and you know, even just the way that she's dressed connects to people I have met when I just came to America, went to high school, and it brings in a whole bundle of sensations and perceptions that are being cued in by this, essentially, this query. Okay. Or for example, this kind of the architectural scene, this kind of crazy, I mean, it's a beautiful photo book, by the way, that, you know, this crazy aesthetic of 80s malls in America. It's incredibly powerful for me. That I'm not sure it will be that powerful for the rest of you. Just like here is, I found an example of 1970s moles. And this image to me, for example, it doesn't sing, it doesn't speak to me. It's interesting on the intellectual level. I can look at it and say, wow, look at this kind of a space age monstrosity there, or this really weird ceiling, you know, or these things that apparently you could sit on in this, right? It's an interesting image to me, but it doesn't speak to me. Okay, and it doesn't speak to me because I wasn't here in the 70s, so I don't have a personal connection to this time and this place the way I do in late 80s modes. Okay, so the interesting thing here is just the mere act of memory recall, okay, of connecting something you see with recognition is a pleasurable experience. In fact, there is a word for it called nostalgia. Okay, and nostalgia, it's something that was actually in the 19th century, it was considered to be a malady. It was a disease. I think it was the disease of the Swiss guards that were away on somewhere and they were missing home. Right? It's this bittersweet, somewhat pleasurable, somewhat sad notion of missing your home or missing something from your past. Okay, so I feel like this nostalgia actually is probably is part of appreciating art, is this the same kind of the pleasure of memory recall. Okay, but that's not all, because let's look at this photo right here, and let me tell you, this is not art. Okay, this is a selfie. Two dudes in front of some door. Okay, nothing very exciting here. Even if I give you the title, and the title is Serge and Alyosha, okay, nobody is going to get very excited about this except Serge here, who wanted me to send him this photo that I took. Okay, anyone can guess why? Philip, you wanna take a guess why was Serge so keen on this photograph?
No, I can't quite see the name on the door, but old office or office of somebody that you were a
So
fan
this
of.
is Serge Bilongi, who is now assistant dean, I think he is at Cornell Tech, or chair, I think. Yeah, the big shot Serge. This is me, and we were office mates back in graduate school, and this was our office. Okay, so this is a very nostalgic moment, but just for the two of us. For the rest of you, this is just some stupid office and some stupid place, and it has no value except for the two of us, right? So here, this is very personal. It's very kind of like it's old memories. I wouldn't call this art though, right? This is just too personal. Okay, I think things get a little bit more interesting when you start to look at kind of more broad types of nostalgia. Let's say, so I was hoping that we get some travelers here, because that's when it's going to work. So I want you guys to guess where a particular images were taken. Okay, so I call this geolocation nostalgia. So, and of course, the more you travel, the easier this is going to be. So could somebody guess where this photo is taken? I want you to just shout it out.
Is it Toronto?
Toronto? No, not Toronto. Not even close.
The Netherlands.
Huh? Netherlands? Slightly closer, but
Zurich?
not quite, not quite.
Turkey.
Your guys are getting around the right neighborhood, but I feel like if the people, if you have been there, this might be much easier. So it looks like nobody has been. This is Prague, actually. This is a Czech tram. This is the Tatra T3, a famous Czech tram. It was actually all around Eastern Europe. The Czechs were making these trams in this very classic color, and everyone who has ever ridden them would remember. And it kind of gets us this shared experience of being on the same tram. Okay, let's try something else. What about this?
Is that New York?
New York? No, no. There's a so these are taxi cabs. I'll give you a hint. These are taxi cabs.
Paris?
Nope. It's, you guys need to travel around more. Too bad we don't have the great Professor Antonio Torralba here.
Then it will be Spain?
Huh?
Spain?
Yeah, it's Barcelona. It's Barcelona, and the reason you know is because that's how the taxi cabs are painted in Barcelona. I'm not sure if it's like that in the rest of Spain, but this is kind of the you know, the standard color for taxi cabs. So again, something that people from a given city would share this knowledge, and it will again bring back all of the memories of either being to Barcelona or, you know, growing up there, etc. All right, okay, you guys need to travel more. How about this one? That should be easy. Oh man, wants to venture a guess?
So some students or people are writing here on the chat.
Okay.
Boston?
Yes, Boston. Thank you. Look at this light fixture. This street light. This is a totally Bostonian street light. You don't have this anywhere else in the world. Okay. I feel nostalgic for the summer I spent in Boston many years ago, because yeah, I mean the buildings are not very descript, right? But this light, look at this. This is a very typical Bostonian light that we should all recognize. Okay, well, I'm gonna, let's see quickly. Anyone recognizes this? Probably not. No. This is my home in St. Petersburg. This embankment, the pattern of the embankment is very unique. It only happens in one river in one city. Okay, nowhere else in the world. What about this? Have you ever gone away, you know, traveled around the world and come back to America, and then the first thing you notice is, I'm home, because it's a yellow strip on the road instead of white. This is a very American thing, that the center strip is yellow. Okay, and that kind of brings you home. Just seeing that makes you realize that you're home. Okay, you guys, I think you need to do more traveling. Then there's even a special website with a contest called the View from Your Window Challenge, where every week they would post a picture like this, a view from a window, and people are trying to guess where it was taken from. City, a country, city, even a particular like GPS location on Google Street View. And people are really good at this. It's really amazing. In fact, Serge, whom I just showed you, he is a fantastic at this. Okay, and people love doing this. And this is kind of the interesting thing. This act of recall, the act of getting to know, to recognize what they have seen before, is something that really makes people excited, because it's part puzzle, part nostalgia, right? And here, of course, it's not as simple as what I have shown, where you have just a single element that gives it away. Here, you need to do compositionality. So I don't think anyone would have any chance. But let me open it up. Anyone wants to take a guess, like country, city, part of the world? No? Philip, you don't want to guess?
I don't know. I'll guess Poland.
Poland, yes. Wow, perfect.
Really?
Yes, it
That's
is
a complete
Poland.
guess.
It is exactly. You wanna try for a city? Now the
Warsaw?
winner pointed out exactly the place on Google Maps, so it can be done, but then you need to do a little bit of internet searching. But yeah, Poland, northern Poland or southern Poland, basically.
Northern, I think.
Yeah. I think this is actually Gdańsk. And basically the way you do this is you look at the type of roof and the color of the roof and the fact that there is basically no fancy embellishments on the side of the building. Okay, like if you go to something like Italy, in France, there is always nice kind of stuff on the sides of the building, embellishments, and in the Germanic part, it's just very utilitarian. Boom, right? But it's not quite Germany, because you have kind of the roofs are a little bit different, and then you kind of narrow it down. Yeah, but very good, very good. Okay, so but what I was saying is that the mere recall, just this kind of the power of nostalgia, is not quite enough for great art. Okay, but there is something more to just the pleasure of seeing something again. And since this is an art class, you guys should be you should be ready for this. But just in case somebody is scared of nudity, you might want to turn off your screen for a couple of minutes, because we are going to look at one of the most famous paintings in the history of Western art, and one of the most scandalous paintings. Okay, this is Olympia, but by Edouard Manet, 1865. It was a huge scandal. In fact, Proust, who went to the exhibition, claimed that if not for the guards at the exhibition, people would have ripped apart this painting. Okay, people were absolutely incensed, and it wasn't because of nudity. Remember, nudity was part of the Western art for a long, long time. So that was not something that took, was scared people off. It was something else. And when I saw this painting first, I was a young kid in Paris. I went to Musée d'Orsay. It's a big painting in the very center of the, like lots of people watching it, and like I didn't get it. I was like, what? I have no idea. Like if you look at the skin tone, it's kind of flattened. It's not, I like from the aesthetic qualities of this painting, I didn't get why was it so famous. Okay, I hope that some of you guys have taken an art history class and you can say why was it such a scandal. Anyone remember from your art history, why was Olympia such a scandalous painting?
Because she was a prostitute?
Well, okay, yes. I mean, but that's not, again, there were paintings of prostitutes before. There was something else about this painting that really just enraged everyone.
Was it the hand placement? I don't know if it was this or a different painting,
I mean,
but
a lot.
there was one where there was
I
a
mean,
hand
there's a
placement
lot of
somewhere
them,
and it
but
drove
okay.
everyone crazy.
Say again? The thing is, this is a fundamentally a huge troll. It's a trolling of the highest degree, because everybody who saw this painting recalled what it was referring to. It was referring to this painting, okay?
Yeah, that's the one I was talking about.
Exactly, the Titian, the Reclining Venus, super famous painting. Everybody knew about it, right? Again, as I said, like, you know, nudity, not a problem. Ladies reclining, not a problem. Lots of paintings like this. It was the juxtaposition. It was not. You failed to appreciate that work of art if you don't connect it to what has come before. So you have a lot of this is recall, but it's also recall plus juxtaposition. You go from here to here, and now we see, oh my God, look at this. This is a modern woman. She is, you know, she's looking straight at you. There is a lot of this. I mean, you know, he replaced a dog by a pussycat here. You have a lot of other things. You know, there's some notions that she might be a prostitute, but she's also like a modern woman. She's looking straight at you. Like, there's a lot of things that enraged people, because it was this like Philip was saying, like the difference, the walking from this to this is what made this an art. Okay, not this painting in itself, but this painting in relationship to what it was referring to, what it was trolling. Okay, any questions?
Sorry, I think that Kenneth Clark wrote something. Do you want to explain what you mean, Kenneth?
Oh yeah, so I guess it's just like the specific terms for this, like in the study of like literature and art and things, is like just intertextuality, and then it's also kind of like parody, right? Like it's the force of its message comes from direct reference and signification to something else, and it only works with that, right? Which is just like the point you're getting at.
Yeah, thank you. Yes.
But like, I mean, that is a specific term for that.
Yeah. I'm kind of talking about this as a you know, as a computer scientist. Of course, yeah. You want to have some, you know, art historians who can tell you much more about this. But I think I'm trying. Yeah, exactly. But it's this is just an example of this, and you can say, well, there is just so much. There is so much more context here. There is the whole you know, historical context. There is the mores and norms of the era. There is like how the prudishness of the Parisians, that they were okay with depictions of nude goddesses, but not with like normal everyday people. Okay, let's look at something completely different. Those of you who are squeamish can turn your pictures back on. Completely safe and utterly weird Damien Hurst. Okay, very famous contemporary artist, and again, you know, a lot of this is recall, right? Now, this is like a lot of it is kind of like memory recall. I would even maybe call it nostalgia. You go to you know, MoMA or something, you see a bunch of dots arranged in a regular pattern. You say, oh yeah, that's Hurst, right? And you feel good because you're recognizing it. So it's kind of like you recognize your favorite, you recognize a song on the radio, or like you recognize, oh yeah, this is Bach playing, right? The same thing here. Part of it is just Hurst has gazillion of these dots. They're hanging as all the museums. They cost a lot of money. People buy them like crazy. And part of it is really this is like a association, a recognition of I have seen this. This is Damien Hurst. Great. Okay. But to me, that's not enough for this to be a great work of art, right? But again, if we situate it in context and we look at what came before this and what came around the same time, and this is a Russian painter, Zlotnikov, and this is something that is in relationship to the Hurst, right? So if you look at this painting, you feel freedom, you feel space, you feel openness, right? And it's kind of it's quintessence of these feelings that Zlotnikov was trying to convey, and as a opposite to this, Hurst was kind of putting you in. He was making you into this very rigid, structured environment. And then now that you have seen these two, here's another Hurst. What are your feelings about this Hurst? What do you feel?
It's a little bit cluttered.
Cluttered. Any other feeling? What do you? Yeah.
Little crazy.
Crowded. I would say crowded. Claustrophobic, maybe. Right? You feel this. You feel like you're not. You need more air. Please, people, let me through. I want to get to the window. Okay. And these are just stupid dots on a 2D plane, right? So you have this. Once you're situated yourself in a particular, to use Philip's metaphor, in particular part of your latent space, now you can directions emerge. And so here is one direction which adds meaning to this to all of these paintings. Now, I was asking Philip about, is there a unique direction? Because here, of course, it's not a unique direction. This is my interpretation. There, I mean, Hurst might have his own interpretation. In fact, he did. He thought of those as like pills, different color pills that you take to live forever. But my interpretation is just as good, and I think maybe better than Hurst's. Right? It's the feeling of freedom and crowdedness as space. Right? But notice that this direction, it emerges kind of directly from the data, but it requires you to be aware of all the data, of all the things that have come before and maybe even after. Maybe I could really only appreciate Zlotnikov's 1965 piece once I get to see the kind of the later Hurst pieces. Okay. Now, you could say, okay, this is getting a little crazy, because what about just screw directions, something completely crazy. This is a famous Russian supremacist masterpiece of Kazimir Malevich called The Black Square, which is what it is. It is really truly a black square. You go to the Hermitage Museum in St. Petersburg and it's hanging there. It's just this black square, like nothing, like it is just that. Okay, so this is like people call it the fixed point of painting, right? It's not really. It's like you cannot have a more abstract, more like nothing of a painting than a black square. And you'd say, okay, how did that get created? That seems to be doesn't seem to be any direction here. It just it's like a total nihilism. You're kind of denying everything that came before, and you just say, okay, screw you guys, right? I'm putting my black square. But actually, even that actually is the ultimate resolution of a particular direction, because look at other Maleviches. This is some of the other Maleviches that he was doing around the same time, and you can see that he was making more and more minimalist notion of space and kind of really relying on geometry and really reducing the amount of color palette. And he was starting to use much more blacks. And given that direction, it's not maybe that surprising that the black square is the ultimate ending of that. And look where he, like, this is how the black square was presented. This is at the exhibition in 1915 in St. Petersburg. This is the black square. This is other Malevich's works. This is where in Russia, this is where you hang your icon, right? In Orthodox, Christian Orthodox in house, this is where you put your icon, right? And so he has the black square, which signifies nothing, but of course it's a big signifier if you're hanging here, because it's basically, it says put it where an icon would have been, except make it black, make it like not number, essentially, right? So you're still conveying a lot of information. And so now you can see that from somebody who goes to the museum, I think in Tate Modern, there is another black square. You go to see the black square, it's like, what the hell? It's like, I don't understand this, right? But if you put yourself in Malevich's shoes, it's perfectly understandable. It's a nice transition. It's a nice direction for Malevich, which wasn't that crazy, right? He wasn't that crazy. It was a very natural destination for what he was trying to say. Okay. And so this is kind of maybe the last point I want to make, is that this creative change, it's usually smooth. Here is an example of where we believe, there is the theory that there is this kind of the Romer gap of art history in the Renaissance. So you have Lorenzo Ghiberti. This is the baptistry in Florence, and the baptistry has two sets of doors. And so Lorenzo Ghiberti was commissioned to do the northern doors in 1424 when he was a young man. And here is his design for the northern doors. Then he went to Rome. He hung around with all the other Renaissance types, and then he came back home 30 years later, home to Florence, and they say, "Oh, ciao Ghiberti, we still don't have anyone do the eastern doors. Since you did the northern doors, we thought it would be nice to kind of keep the same style and have you also do the eastern doors." So in 1452, he does the eastern doors, and a lot of people say that is the kind of the ginormous, like the big bang of Renaissance happened there. Because look at this. These are the northern doors that he does before going to Rome, and this is the eastern doors. And this is not the same style at all. In fact, like, people who lived in Florence at the time must have felt like it was, I don't know, when iPhone came out or something, or when the internet took over in a matter of a couple of years, right? It was like night and day. Like to the Florentine, this probably felt like VR. It probably felt like reality. Suddenly you have depth. You can walk into these paintings. You can feel them. Like, this is so different from this stupid planar, just put a couple of figures on the background and be done with it, right? This is just so much different. And so people think, wow, this is like a huge departure. This is so creative. This is such a big difference. But this is a big difference because, we didn't see what Ghiberti was doing for 30 years while he was hanging out in Rome. And if you look at what he saw in Rome and what he was doing in Rome, you would see that it's actually a very natural transition for Ghiberti. It's just that this transition is missing. We're missing this hole here. It's like Romer's gap in evolution, right? It's the Romer's gap is, there was a gap between fishes that had fins and then fishes that kind of came out of the water and had little legs. And there was no intermediate species in the fossil record. And people say, okay, what happened there? Well, a couple of years ago, they found an intermediate species to fill in this gap. And it was basically, it was a linear interpolation. It was a very smooth transition that the fins were getting bigger and bigger and were like treading the floor of the river, and then it was all very natural for Ghiberti. This was very natural. Just for Florentines looking at this in this kind of a chopped way, it looked like a big deal. It looked very new, but from the point of view of Ghiberti, it was very smooth. Okay, and so I guess the point here is that there might be less magic than we think, because it might be that what we're seeing just the results of this creative process, either artistic creative process or evolutionary creative process, or maybe even computational creative process, that looks like magic to us, but in reality is just a very simple directional walk on the manifold, and then it just it gets punctured because we don't see all the intermediate steps. And here I just wanted to mention a wonderful book that I think gets at this point. It's a book by a psychologist, Valentino Breiterberg, called Vehicles, and it's kind of I highly recommend everyone reading it. It's an exercise of like thought experiment, and he introduces a set of hypothetical robots that, to an outside observer, exhibit very complex and interesting behaviors, whereas actually they are made up of very, very simple things. So here is he builds them up that by the end of the book, these vehicles are like conscious and they have love and hate and all this stuff. But it starts out like vehicle 1 is just getting around. A single sensor attached to a single motor. Propulsion of the motor is proportional to the signal detected by the sensor. The vehicle will always move in a straight line, slowing down in the cold, speeding up in the warm. Okay, very, very simple. And this is what Breiterberg writes about it. Imagine now you would think, if you saw such a vehicle swimming around in a pond, it's restless, you would say. It doesn't like warm water, but it is quite stupid since it's not able to turn back to the nice cold spot. It overshoots it in its restlessness. Anyway, you would say it's alive since you have never seen a particle of dead matter move around quite like this, right? So we're anthropomorphizing this very, very simple setup and kind of adding some supernatural qualities to it, whereas it's really just a motor and a sensor and the one connection, and then he has clever connections where you go towards a light, or you go away from the light, or you do figure eights, and then things just emerge from these very simple behaviors that we interpret as like love, hate, and fear and jealousy and all this other stuff, but it's nothing. It's just the stupid motors being connected in different ways. Okay, and so kind of the moral of this evolutionary fable is he calls it the law of uphill analysis and downhill invention. Machines are easy to understand. You're creating them. Much harder to understand from the outside. The same way for an artist who is creating something, it makes so much more sense to them than for the people who are seeing their art, okay? Because they are seeing it from the outside. And so the psychological consequence is if we don't know the internal structure of a machine, we might tend to overestimate its complexity. We might think there is more going on than there actually is, okay? And I think this is a very important thing to keep in mind. I recently saw a video of an interview somebody did with GPT-3, the OpenAI thing. Let me play a bit. I hope it works.
So I understand that you were trained on Wikipedia. What are some of the things that you learned about?
I learned about philosophy, art, science, math, literature, and linguistics.
Okay, that's cool. And what do you think about humans learning about you?
I think humans will gain new insight into the world around them.
That's interesting. What kinds of insights?
That will provide meaningful answers to any questions that you may have.
All right. So a lot of people, when they see this, is like, oh my God, this is amazing. This is crazy. This is this is like, the singularity is here. And I have a almost like an opposite reaction, which is, I think, even more humbling, which is, God, maybe it's not so fancy and complicated being human. Maybe you can pass on being human without really that much difficulty. By just stringing together a whole bunch of engrams, you can pretend to be a human, and people are going to believe you. So to me, this is actually makes it's more humbling for us humans that it's so easy to impersonate us rather than the other way around. Okay, and I think this is something to keep in mind, that it might be that we are really overvaluing ourselves, and that we are not much more than just people who parrot back things that they have seen, parrot back the nostalgia that they have learned in their earlier lives, and then kind of combine them together with some simple linear interpolation or some simple linear directions and some latent space. Okay, so in conclusion, advances in art, creativity, even evolution, do not happen in a vacuum, right? They are a direct result of what has come before them. They are literally standing on the shoulders of the giants that are the other data, the previous data that has been there. They are just adding a little tiny delta to what has seen before, right? Manet's Olympia is a piece of junk if it wasn't for Titian, right? And Titian was also, of course, not working in a vacuum, right? It's all about connecting your little thing to what has come before. And the same thing for evolution, right? Evolution is just doing one little thing to the design that was already existed, okay? So the creative process might look sudden or discontinuous, but it's actually usually very, very smooth. And I think the main mystery here, and this is kind of going back to what Ali asked about in the beginning, like what is a good direction for study? I think finding these good directions, which way to go, I think that is kind of a big mystery. We don't know how it's done. In evolution, from what we know, it's probably a lot of it is compositionality and just a lot of randomness and lots of search. In creativity, probably similar, plus perhaps analogies, rhymes, lots of randomness, and probably also luck. Okay. So, okay, I think I'm done here, and I hope this was at least discussion inspiring. So I'll yield it to Phil.
That was definitely inspiring on so many directions. So let's see, Ali, do you want, I have a few questions. Is that a good, how are we doing on the time and all this? Yeah.
I think we are, the time limit is 2 p.m., but we can, at any time that you and Alyosha want, we can do.
Okay, perfect. Yeah, I think, I want to ask some things. And also, I think anyone in the audience should definitely feel free just to shout out and engage in the debate. So, I think this is a really interesting idea that change is smooth and creativity is this smooth function, and it doesn't always look that way. And one of the things that has puzzled me for a long time, and I know, Alyosha, you've also thought about this, is how do you quantify novelty, and what does novelty really mean? Because novelty or innovation, if you measure it with something simple like Shannon's entropy, just how much information in a mathematical sense is added to the system, well, it's trivial to get novelty. You just make a random image, random white noise, just random speckles. That's the most novel you can possibly be. But when we say something's novel or innovative, we definitely don't mean that. And I'm just wondering if this story about smoothness and incremental change and connecting to the context could shed light on what meaningful novelty is. Because clearly, if somebody made the random noise painting out of context, nobody would care. If somebody made it as a moment when art was evolving toward more randomness, like Jackson Pollock did things like this, and that was within context and incremental. But if it weren't in context, it would be high information and very mathematically novel, but not novel according to us. So yeah, I wonder, Alyosha, your thoughts on, does this help us get traction on meaningful novelty?
Exactly. That's what I was thinking. When one thing I forgot to mention is like the Malevich's black square. It appeared in 1915, but it could have appeared, you know, a millennium earlier or later. Like, why did it appear then and not before, right? Well, because it probably did appear before and nobody cared, right? The right kind of novelty is a novelty that can get incorporated basically in your latent space. That is kind of it needs to be connected. It needs to be some destination of some direction. So for Malevich and others around him at the time, this was, they could see this as a goal. Before that, it was just kind of there was no direction to it, and so it was just some random thing. So it didn't make sense. It didn't make sense as art form because it didn't connect. And after that, right now, you know, I can paint a black square. I can try to sell it to SF MoMA, and then they're not going to buy it because, you know, the moment has passed. There is already a black square. It's too late. It's not novel anymore. Even though maybe I can use some different, I can do a gray square or something, or an orange square, right? But it's not, it's over, right? So I think it is exactly this, that you need to be you need to do the right thing, but also at the right time in the relationship with what has been done. So it needs to be pushing along some direction. And if you're too early, then it's too far, and so it's not smooth enough. If you're too late, then it's already been done, and again, you're kind of doubling back. So I think that's exactly that this notion of smoothness is absolutely critical for this. Yes.
Interesting. So now I'm wondering about science, because it's a similar process of innovation, just like art. And I feel like there was an era of AI when everyone kind of knew each other and everyone knew what the narrative was, and different people had different narratives, and then you can introduce a novel narrative. And kind of in telling stories like Data++, that's something that, you know, I'm trying to replicate in this era. And I think Alyosha has done, you know, always had a really good job at having the story, the paradigm, right? And that seems so important for kind of identifying this meaningful novelty. But it also feels to me a little bit like we're losing that, or it's becoming overwhelming because there's a million archive papers every day. Not everyone knows each other. The field is so big. So yeah, I wonder, Alyosha, if you think that this is an issue with the field of AI right now, and how we could improve things in that sense, or maybe there are narratives and there is kind of a coherent story in the field that is being incrementally advanced.
I think narratives emerge later. I think, you know, again, if we connect to art, you know, Manet, nobody cared about him, you know, during his lifetime. Cézanne, like, couldn't sell a single painting, and now it's like he's one of the most you know, expensive painters ever. I think people are trying different things. They're trying different directions. They might have a narrative in their head, but it has not taken over. And the same way when you when you find some sort of a kind of a scientific narrative, there's always people who go back and realize, oh my God, there was a paper on this 20 years earlier and nobody noticed it, right? So why didn't anyone notice back then? Well, because it was the same thing as with the black square. It was not connected to a narrative. It wasn't smoothly connected to what people knew, and people just didn't know how to deal with it. They didn't know how to connect it, and so they just ignored it. And it took time either for that paper to get rediscovered or for somebody else to basically redo the same thing again, but then connect it to a narrative and get the community to understand it. So I think it's kind of it's always been like this. There, in a 19th century Paris, there was lots of crazy painters doing crazy things that people were horrified about. Only a few of them we still remember, right? All the rest of them disappear. It's the same thing with at NeurIPS. There is gazillion papers that do some random stuff on MNIST that doesn't work on anything else. Only a few will get remembered. I wish we knew which few, right? But we don't. It will emerge over time. The narrative will emerge. But I think it's absolutely crucial to try to get to these narratives, to try to come up with stories. And I think like your data plus story, we don't know if it's right or not. It might not be a good story, but it's a very useful narrative to try to see how everything fits into this narrative. And if it does, it might allow us to appreciate some papers that maybe are already out on archive, but nobody can understand them because there is no narrative to put them into, to put them in the context. So kind of these narratives, they provide context for interpreting other work. And all of this gazillions of random papers sitting on archive are just waiting for somebody to place them in their narrative. Yeah.
Interesting. So I might be looking at history through rose-colored glasses, thinking that the era before me was so clean and everyone had a story, but it was just as messy.
This is why I hate reading modern paper. Like I don't read contemporary papers. I read like 10, 20-year-old papers. Why? Not because there were better papers 20 years ago. No, it's just that if I read a 20-year-old paper now, the only ones that people still remember are the good ones. So I let history filter quality for me. I don't have to worry about if it's a good paper or not, because if it's not a good paper, nobody would remember it 20 years later, right? So yeah, I mean, there's always been a lot of junk. It just that we now benefit from the narratives that cleaned it up for us in the past, but in the present we don't have that yet.
So I finally have gotten around to, or I'm in the middle of Why Greatness Cannot Be Planned. It's a book that Alyosha suggested years ago, but also I think maybe, Ali, maybe I've wanted the authors coming to talk, or I think Jeff Flynn is coming later, who is one of the cohort who contributed to that book, but it's Ken Stanley and Joel Lehman. And it's a really interesting book. It's about how if you try to plan for some kind of objective function or some kind of great success, you're probably going to be misled. And if you just explore interesting threads and get a little bit lucky, you'll end up somewhere you didn't expect, and you might be more successful. And it feels really relevant to the points that you're bringing up, Alyosha. But also, okay, I'm halfway through the book, so maybe they tell us how you can plan it after all. But it seems like the thesis is no, it's actually a lot of luck. And so we're telling these narratives, we're trying to create stories in our mind, we're trying to find the right direction. But at the end of the day, is it just luck, or to what degree can we plan, or should we be planning?
Right. I think that's the open problem. That is to me the open problem. So we know that like in evolution, a lot of it is luck, right? Most of it is luck, because evolution can afford to just try a gazillion things. Now, it's not just dumb luck, because there is also compositionality, right? So evolution doesn't have to try every possible combination of every single thing because it can do it in a kind of compositional way. And so you get that very powerful like log n benefit from that kind of boosted up a lot. Now, in terms of kind of human creativity, I feel like there is something else. I feel like, there are people who, I don't know, Mozart, it just, or Bach, it just doing so much amazing stuff and having so much of it so fresh and creative. There's got to be something more than just luck. There seems maybe they stumbled upon, they discovered the pattern by chance, and then they were just kind of milking that pattern, and then none of us kind of figured out this pattern yet, and they understood it, and then that just kind of you sample using this pattern, and something seemingly rich comes out, maybe. But it might just be that there is something about kind of figuring out how to be lucky. And I think I think we need to figure this out. I think we need to try to research this because, well, as computer scientists, we don't have computers powerful enough to do evolution for us. So we cannot just rely on dumb luck, or as they call it in robotics, reinforcement learning, right? We just don't have any resources for this. We have to have something else. We have to somehow get lucky. And so I think this is a very key thing to try to figure out. Yes.
This connects, I think, back to the whole latent space stuff, because I think one way to be lucky, or one thing that maybe Mozart had, is that pattern had identified like a better latent space, a better vocabulary or grammar, and then could do random searching with that good grammar.
That's right.
Yeah,
that's right. Once you know the lingo, you can improvise in that lingo.
Yeah.
Right. Once you know the milieu, you can now now your randoms or your explorations are much more powerful, because exactly. But
okay,
then the milieu itself, the lingo is also kind of random, right? So
yeah, but if you get lucky enough to get the milieu, then you're okay. And maybe that goes back to you're asking, okay, data plus, well, the operations can be done data too, but data is the wrong medium. It's not structured in a way that does things that we consider realistic or interesting from a graphics or visualization perspective. Maybe we can open it up to a few questions from the audience.
Mm-hmm.
I would like here to add that I agree with Philip in the sense that this data plus is also maybe because the way that we look at, I think also Alyosha mentioned the way that we look at our surroundings, and for instance the big GAN that you look at it's basically compresses how people have collected the images and the type of biases that there are in the images. For instance, maybe rule of third is one of the biases that we like to see in the images, and we see cats or dog in specific poses that we like. And that type of collection caused to have that specific type of latent space. So maybe the smoothness also that Alyosha was talking about, in a way, is captured by us and is given to this notion of latent space and data plus.
Yeah, and I do think, especially for things like DALL-E, which are, as we were talking about, trained on language and curated, data, it is kind of like imitation of all of this human knowledge on the internet. But that's kind of a bad thing if we want some scientific understanding of how you evolve intelligence from, the Big Bang. But it's a fine thing if you just want to find, it's a really good medium because it captured and compressed all that structure on the internet that humans already came up with. Not the whole internet, but I guess they seem to have gotten a big fraction of it.
Right. It could be the lingo of that could be used to kind of to go farther. Just like natural language. Once we got to natural language, human culture could evolve much faster, right? Because you compress a lot of ideas in the language, and then your ideas can evolve faster. The same way as, coming up with numerals allowed mathematics to progress much faster than if you were like ancient Greeks and like writing everything out in long words because you didn't have a notion of like a formula, right? Having the right lingo, like F equals ma, right? Coming up with the abstraction itself was a huge step forward because that like allowed for all the other things to kind of to be much simpler. Yeah.
It makes me wonder if so we were saying, or you were saying, Alyosha, that it's humbling that something as simple as GPT-3 can act like a human. But maybe it's also that it's standing on the shoulders of humans and it's going to surpass us. Not GPT-3, but I think something will surpass us. And we kind of maybe we can think of it as human evolution gave the lingo to the next generation of AIs, and then with that new lingo, then they can abstract more and do more powerful things. I'm not really saying anything new here, but yeah.
No, I mean that's true. That's another way to think about it I guess these two are not incompatible. It's basically we are pretty simple, and then this can make computers a little bit more complex than the humans. Yeah, that's true.
Yeah. I see that, Simon, you asked a question in the chat. Do you want to say that out loud, or I can respond?
Sure, I can ask it out loud. So I asked,
Great.
Can you explain more about the differences that people would have to adapt to when using generative models or data plus instead of raw data?
Yeah. So these are all kind of fresh ideas. So I think that's going to be something that I hope people, and I know people are already thinking a lot about that, right? Data plus is my term for helping you understand it, but it's already a paradigm in the field, working from models. And one big difference is data sets are huge, and if just in terms of engineering, like infrastructure, to work with data at the scale that AI systems currently use, you have to have a huge database. You have to have a million, threads that are just loading data into memory and back and forth. Whereas the models, so just as a concrete example, the images I was showing, which look really realistic, that were samples from models, were samples from a model that is a few hundred, or maybe a few gigabytes, a few hundred megabytes, maybe a few gigabytes. The data that was used to train that model is hundreds of gigabytes. It's probably 1,000 times as large as the model. So just from an infrastructure perspective, we're using 1,000 times less storage when we're working with the models rather than directly with the data. Like Ali was saying, these are compressions, and compression is why they're powerful, because by compressing you get abstraction. So just in terms of engineering, you already have this dramatic difference, and that's one difference. I think there's a lot more beyond that, but that's a very concrete one.
Do you think there's anything that will be more difficult or that people will have a difficult time adjusting to?
Yeah, I mean, I should, I don't want to say it's all positive or that like data is going to go away. I don't think that will happen at all. I just think this is a paradigm that already exists and it's going to keep growing. Certainly the data itself is kind of the gold standard. Like a model learned from data can't do more than the data itself can do. Like theoretically, there's not any more information in the model than in the data.
Well,
okay, it's a little, yeah.
Maybe not. Maybe not. Maybe there is like this emergent, right? Emergent something or other.
Yeah, I think you're right. It's actually, what I'm saying is not true. I was trying to say
none of our current models can do that, but
yeah,
in principle, there could be, there could be like a Mozart model that discovers something that wasn't in the Mozart data.
Yeah, I think so. Yeah, I guess I was kind of referencing this idea of the data processing inequality, that the model has less information than the data, but that's only true in a very narrow sense. And I don't think it's really a meaningful sense right now. I think the model can do a lot more than the data.
I agree with you that current models don't, because basically I think all that our models do right now is an interpolation. But if we could have models that can do extrapolation, then we should be able to do some. We should have something emerge that is completely new and creative.
Yeah, and I have to say, it's a really exciting time because I actually feel like the models are starting, the first signs of extrapolation are here. And the most obvious one is compositionality.
Yeah.
And the largest scale demo of that is DALL-E. So to me, what was so shocking and impressive about that was just, it starts to look like extrapolation. It's really hard to say because it's trained on, they didn't even tell us how many, it's probably hundreds of millions of images. But some of the things it's doing is just, I think, implausible to think that the internet had that photo. You can really do these, like change the elephant's color. Like, okay, the combinatorics are so large, it can't really exist on the internet. But we'll see. Yeah, there'll be more analysis, I'm sure. I hope that all becomes public.
I also wanted to ask a question. This is for both of you and mostly for Alyosha. One question that we ask in this class is that what is the relation between AI and art and the interpolation between these two? For instance, in your work, we see that narrative that you are talking about, for instance, you have this paper that what makes Paris look like Paris, and this is completely computational. Or you have this work that I saw, I think it was a CVPR 18 or 19, which it was actually trying to find those repeated patterns or geometry that some other painters also had in their paintings. And I can go on and on with the things that I have seen in your work in generative models as well. So the question is, what is the relation between art and AI in your work and in your narrative work?
So I don't know what AI is really. So I wouldn't want to say AI because that's just like nobody really has a definition of that. I mean, we can say machine learning or we can even just say computation, right? I think computation is maybe the right way to think about it. I feel that there is a very strong connection between art, creativity on one hand, and evolution on the other. Well, Philip knows I have been big fan of evolution, for a while, and as an inspiration. I'm definitely not a biologist, but as an inspiration for what we are doing in computing, and I feel like it could also provide a good way to think about art as well. It's or even like any other kind of a creative discovery process like science, which is this frontier, forward moving frontier that is part search, part luck, and part some sort of what we call, like, intuition or good taste, that moves it forward. Okay, and I think this is there are more parallels than we care to admit, because you can say that, well, the difference is that evolution has an objective, it's like a propagation of the species, but art is completely objectiveless. No, evolution is also objectiveless. It doesn't have any objective. The kind of the propagation of the species is all emergent quantities. Like the idea of a species is an emergent property. The idea of propagation is emergent property. Like even the idea of death is something that is actually evolution created for its own devices, because it was a better optimizer than if you have organisms that live forever, which there are some. Actually, we have a couple of organisms that we know that do not die. It just doesn't seem to be as efficient as of a search than the ones that do. So in a sense, I think there is a lot of commonalities between that, and we could imagine that in some future paradigm, somebody would just say that art is just the frontier of evolutionary creative process. This is like, you could think of art as being something that just like at the forefront of thinking of new paradigms and thinking of new ways, and then something that was art 50 years ago becomes artisanship 20 years ago, and becomes something that we all do today, right? There are plenty of examples of things that kind of migrated from art to artisanships to just like everyday consumerism, right? And this is why just like evolution, art does not stay still. It keeps going forward. And I think computation is also can be thought in that sense, that there's computation for a specific goal. You have an objective function, and you just run your favorite optimizer to get there, right? That's kind of the boring way to think about computation. And then there is the computation with an kind of a open-ended objective, right? So we have a paper on curiosity, where we have an agent whose objective is to be curious and to kind of to search out new experiences, right? And that seems to be something that allows us to kind of to learn more about the world. And I think this is maybe the actual AI, like the true AI, is in that idea of a objectiveless exploration, and then it shares a lot with art, right? It just that in one case it's humans doing the search, and in the other case it's computers doing the search. So I think there's a lot of connections, but I think we're also just very early on this road. There's plenty of exciting things to do.
Excellent, thank you.
Cool. It looks like we're just about out of time. Any last questions or comments? Cool. Yeah, this was really fun for me.
Oh, it's great. Always great to chat with the great Philip and Ali, of course, too. Thank you for organizing, and
Thank you
thanks
so much.
for indulging.
Thank you so much for Alyosha and Philip. It was really absolutely refreshing and very novel, actually, I think, from what I have seen in the past. So I'm very excited about, this sharing this discussion later, this public, and thanks again.
Thanks. Bye.
Thanks and thanks for the questions and for everyone for sticking around. Okay, bye.